Now, with these inequalities having larger numbers, number of solutions, such as x plus 3 is greater than or equal to 8, where x is greater than or equal to 5, there's more than one answer. So these are called sets of numbers. Anything can really have a set of numbers. Some have many, some have a few. But everything has a set of numbers. For example, your natural numbers can be considered a set, where 1, 2, 3, and 4 are in it. If we call this the set A, it would include 1 to 4. These squiggly lines generally go around a set of numbers, and I put this in standard notation of including 1 to 4, just for example. Now let's go on with the whole numbers. We'll call this B. 0, 1, 2, and 3. In set B, there's 0 to 3 in the solution set. Now here's a few different kinds of sets here. Right now, A is a intersect with the whole numbers, where A intersects B is going to be shown on the number line here. The whole numbers include 0 and go up to 3. The natural numbers start at 1 and go up to 4. They intersect where these numbers don't exclude here and these numbers don't exclude here. Basically, these sets right here between 1 and 3. So the intersection of A and B is 1 to 3. Now there's other kinds of number sets. For example, in its raw form, the natural numbers are a subset of the whole numbers, because the whole numbers actually include one more digit than the natural numbers, that number being 0. So A has the subset B, A being the naturals, A being the whole numbers, and B being the natural numbers. Now, if you want to combine two sets of numbers, for example, you've got your naturals as A and your wholes as B, A union B combines two sets. So we say 1, 2, 3, and 4, and this will be 0, 1, 2, and 3. Then this will be all of these numbers and all of these numbers combined. So it will be 0, which is going to be the lowest part here, and the highest part here, 4. So the union of A, B is 0, 4. Now, when you've got things like inequalities, you generally have a way to graph them. Well, sometimes you have to graph them on a number line. So something like x plus 3 is greater than or equal to 8 is going to be a set of numbers. In this case, x is going to be greater than or equal to 5. Now, this means that any number that's 5, 6, 7, or 8, or up to infinity is going to be greater than 8 and fit into the solution set. On a number line, it's shown in interval notation, where where 5 to infinity is shown in standard notation. On a line, this is how the solution set would work. When you're writing down answers, however, you'll want to use the standard notation, where if you're including a number, for example, greater than or equal to 5, you're going to be including the number 5 with a bracket, and since infinity has no definite number, we're giving it a parentheses. You would also use this if a number were definite and you're only using a greater than number. Okay, so let's work on exponents. Exponents are numbers in generic form that show how many times a base, b, is multiplied by itself. For example, 3 to the second power, or squared, is equal to 3 times 3. 3 to the third power, or cubed, is 3 times 3 times 3, which is equal to 9 times 3, 27. If x is negative x instead, then b will be 1 over b to the x. A negative exponent flips and reciprocates this number and turns it to 1 over whatever your number is. Interesting enough, if you've got 1 over b to a negative exponent, it becomes b to the x. Now, an variable to an exponent is equivalent to x times x times x times x all the way up to x to the y. In expanded form, you would show how many, for example, x to the fourth has a degree of 4. In expanded form, x times x times x times x. You might want to use this sometimes when you're going to simplify an expression, or if you're rationalizing an equation.